Hey guys, this is Jacob here, and I'm coming back with another math tutorial. Right now we are doing chapter 3. This is section 3.2, graphing and solving radical equations, and this is page 128 on your textbooks. Ignore that it says page 179 over here. So we're doing 6a, and this says solve the radical equations A algebraically and B graphically. And we are given f of x is equal to root 2x minus 3, and then outside of the root, minus 3 is equal to 0. So one of the first things that I like to do when dealing with these questions is find the domain. And when we have a radical and we want to find the domain, we look at what is inside of the radical. So, and then we set that to greater than or equal to 0. So we have 2x minus 3, I'm just going to do this over here, is greater than or equal to 0. So if we move the 3 over, we will add a 3 to both sides. And then we have 2x is greater than or equal to 3. And if we divide both sides by 2 to find the x, we will find that x is greater than or equal to 3 over 2. So we know that, and 3 over 2 is also 1 half. So we know that all of our x values are going to be greater than or equal to 1 half. So now that we know that, I'm just going to write it over here. This is x is greater than or equal to 3 over 2. Okay. So now what we want to do is we want to try to find an x-intercept, because we know that that's probably going to be a good place to start, finding values of x and y. So when we are finding an x-intercept, we once again want to solve for x. So if we write out root 2x minus 3 is equal to 0. The first thing that we want to do is isolate the radical. So we will move the 3 over to the right side. So now we have root 2x minus 3 is equal to 3. And then we want to get rid of the radical because we don't like that. So we are just going to go right ahead and square both sides. Oops, something went wrong here. That happens sometimes. But I think I just might be able to erase it. Yes, and I can't. Great. So going back, we want to square both sides. And when you square this radical, you just remove it. So now on the left we have 2x minus 3 is equal to 3 squared, which is 9. And then we want to get rid of this plus 3, or minus 3 rather, on the left side. So we are going to add a 3 to both sides. And now we have 2x is equal to 12. And then let's just get x by itself, and just going to divide both sides by 2. So we have x is equal to 6. And so we know that our x-intercept is 6, 0. So that's great. Now just let me erase this because I'm going to want to make, oh, whoops. Okay, sorry about that.
Hey guys, it's Shane.
That was weird. So now let's just get rid of this stuff, and as long as we still have that x-intercept, that's good. I might just have to cut that part out, but we'll see what happens in post-production. So now that we have that, I find it very helpful to make a little table of values of our x and y values. So, like we said, since we already have an x-intercept, which is 0, and then we know that our y value will be 0. So right off the bat, we can just plot that point. I'm going to use a nice color blue for our graph today. So we find where 6 is and we find where 0 is, and right there on the x-axis we have the point of 6, 0. So now what we want to do, obviously, the next logical step, let's look for a y-intercept. So what you want to do when you want to find a y-intercept is you set all the x's to 0. So we can do 2 times 0 in the radical minus 3 minus 3 is equal to the y. So when you do 2 times 0, you get 0 minus 3 minus 3 is equal to y-intercept. But then we have a problem because we're left with negative 3 inside of our radical, which has it can't be done. It simply can't be done. There's nothing that we can do about it. So there's no y-intercept, and so that's also going to help us out because we will know that if we have a graph that touches the y-intercept, then obviously we've done something wrong. So that's just good information to keep in mind. And when you're graphing other types of graph, it's always good to graph the y-intercept because it's not going to be every single time that you don't have a y-intercept. So continuing on, we're going to want to graph things obviously to the left of this x-intercept so we can see it on this graph, but they need to be greater than or equal to 3 over 2, which is 1/2. So since we know that it's got to be greater than this, greater than or equal to, another smart value to do is 1.5, which is 3 over 2. So now, if you want to find this, then what we need to do is look at the function, and wherever we see x, plug in 1.5. So if we were to write that out in the radical, you would have 2 times 1.5 minus 3. Let me just extend. Minus 3 is equal to our y value. Oops, I forgot a little bracket over here. So 2 times 1.5 is equal to 3, and then 3 minus 3, and then outside of the radical minus 3 is equal to y. So this is 0, so that's nothing. Minus 3 is equal to y, and since this is nothing, when x is 1.5, y will be negative 3. So we also know that that is a point that we can plot, but we are going to save that until we graph this algebraically. So going with the trend, we want to continue using values of x that are greater than 3 over 2. So another good one to do is 2. So we have 2 times 2 minus 3, and outside of the radical minus 3 is equal to y value. So 2 times 2 is 4, minus 3 is equal to y. So then we have the square root of 1, which is 1, but we'll do that in another step just so we can be clear. So square root of 1 is 1, minus 3 is equal to y. So when x is 2, y is negative 2, 1 minus 3, negative 2. So now we can also write that. So obviously, you can essentially do any point that you want that is greater than 1/2. But and I've done a few, but there's a few just more key points I would like to do because they help to shape a graph. So another point that I want to use, another value of x is 4, because this one is another helpful point in shaping the way our graph looks. So once again, we will have a radical and 2 times, now we're putting 4 in for x, minus 3 on the radical, minus 3 outside is equal to what our y value will be when x is 4. So 2 times 4 is 8, minus 3, and then outside minus 3 is equal to y. And then we have square root of 5 minus 3 is equal to y. And this is it's a bit of an ugly number, but you end up getting negative 0.7 is equal to y. So when x is 4, y is negative 0.7. And then obviously, you could do points like 4.5, 4.5, 5.2, kind of do whatever points you want. But obviously, since we have 6, just the last point that I'm going to want to do real quickly is 8 is going to be the last point that I have when x is 8. Because we kind of want to just keep with the trend of what our graph is going to look like. But obviously we only have so much space here. So, oops, my bad. Keep on forgetting about that. So, like I said, the last one that we want to do is 8. That's an ugly 8, but it's an 8. So, again, we have a radical. This is going to be 2 times 8. We're putting 8 in for x minus 3. Outside is minus 3 is equal to y. 2 times 8 is 16 minus 3. Outside minus 3 is equal to y. 16 minus 3 is 13 minus 3 is equal to y. And again, this is kind of an ugly number, but when you solve it, you find out that 0.6 is equal to y. And so that is the last point that I'm going to plot there. So now that we have a bunch of points by solving our function algebraically, we want to take this onto the graph and see what it looks like. So, already by this level in grade 12, you should be able to identify what a radical, a radical graph will look like. And so, we already know what it should look like. So since this isn't negative, it should look something at least remotely similar to this, which is, this graph is this, the root of x. It should look something similar to that. So if we can get something similar to that, then it should make sense. So let's go back to the blue. So like I said, when x is 1.5, y is negative 3. So we find 1.5 and then negative 1, negative 2, negative 3. So there's a point right there. And then when x is 2, y is negative 2. So we go over 2, and then we go down to negative 2, and it's right there. And then when x is 4, y is negative 0.7. So around there. And then when x is 8, but that's off the graph, y is 0.6. So we know that it's going to continue in this trend looking like this. And there's going to be an error here. And that's pretty similar to what we had over here. Obviously, it's been translated a little bit different, but it's a similar shape that we have here. So, hopefully this will help you guys when you want to figure out what a graph would look like by using algebra, and then how you can put it on the graph graphically, and just the important things to keep in mind, at least for me when we do this, is to find a domain, because that's going to tell you what your x values can be, to find the x-intercept, and to find the y-intercept as well. And then once you do that, just remember to plug in values for x, plug in values for x. Obviously, you don't need to do it in this order, but this is the order that I find that it helps. And then the last step is the graph, and hopefully it'll look right, and you guys will have the right answer. So I hope that you guys enjoyed this tutorial. I hope that it helped you guys a lot. I'm definitely going to be back with some more tutorials later in the year. So have a good one, and thanks for watching.